2.4, rates of change and tangent lines. So overall, I would say this section's actually pretty easy. So I don't think you'll hate it. I think 2.3 is probably the hardest in this chapter, and you got through that, so. All right, so first, average rate of change. Now, does anybody remember when I used to say rate of change in your other class, I would say think something? Yeah, slope. So kind of the same deal here. It just looks a little different now, but same principle. So it's the amount of change divided by the time it takes. Okay, and that doesn't necessarily mean like word problems. It's just like the principle of it. So basically what happens is they're going to give you a point or an interval, and we essentially do the function at the second endpoint, or like the actual like the right endpoint, I guess, minus the function evaluated at the first endpoint in there over the last point minus the first point. So it looks very similar to the slope formula. It's just a slight modification of it. So it would be f of 0.2 minus f of 0.1 over 0.2 minus 0.1. And that would be like if they gave you the interval from 0.1 to 0.2. So essentially, we're finding slope, and we're going to be like using that to write tangent lines to that. So just a quick example of this. If we have f of x is equal to x cubed minus x over the interval from 1 to 3, we would have the function evaluated at 3 minus the function evaluated at 1 over 3 minus 1. So if I plug in 3 to f of x, what would I get? So basically, what's 3 cubed minus 3? 3 cubed. 24. You still half asleep. And then how about f of 1? 0. So 24 minus 0 over 3 minus 1, which is 24 over 3. Nope, 24 over 2. I was like, oh, the 0 and 1 cancel. Don't know why that went through my brain. Disregard. So that would be 12.
Where did the 0 come from?
F of 1. 1 cubed minus 1 is 0.
That is.
All right, so this next big thing in here, so that's average rate of change. So now we're going to move into tangent, like tangents to a curve. So basically it's like if you have a curve, it's a tangent is intersecting at like one point. Okay, so that would be the tangent. And we're trying to find, in a sense, the slope of that line is kind of what we just did. So, let's get, all right, tangent to a curve. All right, I'm going to say this person's name. I think it's a name. I don't know how to say it, so I'm going to say it what it looks like. So use Fermat's method for defining tangents to produce formulas for slopes of curves and rates of change. So first we start with what we can calculate. The slope of a secant through P, not B, P, and a point Q nearby on a curve. To find the limiting value of the secant slope as Q approaches P along the curve. And then 3, define the slope of the curve at P to be this number, and define the tangent to the curve at P to be the line through P with this slope. Next we have the slope of a curve. So the slope of the curve y equals f of x at a point P, which is a and f of a, is the number m is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. That's one of those that you need to make sure you know, provided the limit exists. Now, I think we may have seen that formula last year briefly when we did a little bit of calculus in pre-cal. We may have already seen that formula this year, I don't remember, but next is normal to a curve. So you're going to have problems that ask you for the tangent line, and then you're going to have problems that ask you for the normal line. So a normal line to a curve is basically perpendicular to the tangent line. So the normal line to a curve at a point is the line perpendicular to the tangent at that point. So in most every case, it'll ask you for the tangent and the normal. So you'll find the tangent, then you'll use the slope of the tangent, find the perpendicular slope, and then re-plug stuff in and essentially get the second line. And then the last thing is instantaneous rate of change. And so this is position with respect to time. So WRT is with respect to, and that's going to be the limit as h approaches 0 of f of t plus h minus f of t all over h. So essentially, that's the same formula that I starred up there in orange, just modified for instantaneous rate of change versus the slope of a curve. So essentially, a just got replaced with t for time. So we'll look at some rate of change problems tomorrow. We don't have enough time to justify starting problems, and I know some of you have a test that you might want to study for. And then we'll do some problems with limits with the stuff of plugging things into these equations here. Finding tangents and normal lines. And, go from there. But like I said, I think this section's relatively easy overall. Because it's pretty much find the slope and write an equation of a line.